The Sundial Bridge is located in Redding, California at the 300-acre Turtle Bay Exploration Park. The bridge is a 700-foot-long cable-stayed pedestrian bridge which spans the Sacramento River and connects the north and south campuses of the Exploration Park. Designed by world-renowned bridge designer and engineer Santiago Calatrava, the bridge was completed in June of 2004 and opened to pedestrian traffic on July 4, 2004. The concept for the bridge began in 1995 as an attempt to boost tourism to Turtle Bay and to Redding, California. An initial design of a single-tower suspension-span bridge was chosen by the community with a modest $2.8 million budget. This design was soon rejected because of lack of appeal to the community. This is when Redding reached out to Calatrava. Calatrava's design broke ground in 1999 with an initial estimate of $13 million, which swelled to $23 million upon completion. The design and construction of the Sundial Bridge was to ensure no environmental impact on the river. The tall pylon and cable stays allow the bridge to fully span the Sacramento River, allowing it to avoid the nearby salmon spawning habitats. This design involved tremendous engineering in the bridge's foundation system. With only two independent foundations on either side of the river, it was extremely important they were designed to resist overturning from the massive weight of the structure. The foundation system is comprised of over 115 tons of rebar, as well as over 1,900 cubic yards of concrete. The initial feature of this structure that grabs your attention is the 217-foot tall inclined pylon. The steel constructed pylon is the backbone of the structure, which attaches the galvanized cables to the bridge deck, giving the walkway its main support. The pylon is constructed of steel plates varying in thicknesses from 1 inch at the base to 5/8 of an inch at the top. Due to the size, the pylon had to be constructed in segments and welded together on site. The pylon is cambered both to the north and to the east to compensate for deformation that would occur after the addition of the dead load and to account for the fact that the cables are attached on the west side rather than in the center of the pylon. The pylon is constructed at a 41-degree angle to the north, which acts as a sundial on a park constructed just behind the bridge. Although the only time the sundial is exactly accurate is the summer solstice. On June 21st, the tip of the shadow moves at approximately 1 foot per minute, so the Earth's rotation about its axis can be seen by the eye. The sundial bridge deck is made up of tubular steel sections. The 23-foot wide, 8.5-foot deep steel pipe trusses consist of a 14-inch diameter bottom chord and two 11.25-inch diameter top chords. The cables are fixed to the truss off-center, so the truss, like the pylon, was cambered to account for the deformation resulting from the asymmetrical loads. The deck consists of 18 40-foot sections, which were fabricated off-site and installed by crane from the riverbeds. The sections were installed from the north side with the pylon so the cable stays could be attached as the deck was cantilevered out over the river. The 14 galvanized cables attached to the deck frame and attached to the pylon. These cables transfer the support from the pylon to the bridge deck. The bridge deck is composed of 2,240 non-skid glass panels set in a steel frame gridwork. The panels allow for natural light to pass through the bridge, resulting in less of a shadowing effect on the river and more light to the salmon spawning below. At night, the bridge deck is illuminated by 210 lights from the underside to enhance the pedestrian walkway. The Sundial Bridge is truly a remarkable piece of architecture and engineering nestled into the small town of Redding, California. The minimal effect on the surrounding environment, as well as the architectural beauty and increase in tourism, make Calatrava's Sundial Bridge a stunning success.